Welcome to Fast On-Demand Analytics with Alluxio and DCOS. My name is Keith, and I'm a product manager here at Mesosphere. And today I'm joined by Neena, VP of Products at Alluxio, and Adit, a software engineer at Alluxio who worked on this integration. So to go over the agenda, we're going to kind of set the context around what we see going on with our customers and across the enterprise industry and how DCOS fits into that. After that, I'm going to turn it over to Neena, who will give you an overview of Alluxio Enterprise. Then we'll talk a little bit about our joint integration that we've been working on. Follow that with a demo of the integration. And finally, we'll close with question and answer. So an opportunity for you, the audience, to ask us any questions you may have and for us to get you those answers. So, over the past 10, 20 years, the IT industry landscape has really been changing. And I think that everyone is finding this now that almost every company out there is becoming a software company. And there's a famous quote from Mark Andreessen called "Software is eating the world." And I remember telling people about this quote 4 or 5 years ago, and people's heads would kind of turn. But now I think everyone really understands it, that software is being used to disrupt a broad range of industries. And on top of this, you have this new phenomenon where we live in this always connected world. So everyone that you know, everyone that I know, has a mobile device in their pocket that's always connected. They basically have a computer in their pocket. Not only that, but connected households is becoming a thing now. On average, people have 13 connected devices in their household. And so in this always connected world, what you have are these devices that are creating streams of data. And as we see more and more devices, you're seeing more and more data come in, right? So you have this new phenomenon where people are using software to disrupt traditional industries, and all of your users are connected at all times and are always available with a computer in their pocket. And so this creates a lot of exciting opportunities for people to build new applications and connect with their customers in new ways. And so in this always connected economy, software really is your business. And what does this mean for companies? Well, it means they need to build more applications, right? Everyone has to continue to work with their customers and connect to their customers in a meaningful way and deliver value for their customers. It means that you need to innovate faster, because you're not the only company out there that knows that customers are expecting more now, right? So you have to be able to build and deliver features faster, and the customers are really expecting that. And then customers are getting used to this always connected world, and they really expect your applications to run like a service, like an always-on service, right? So companies are being asked to modernize their IT organizations and transition to this world where you're delivering secure applications that are always available to your customers. And so, this requires that enterprise companies transition to this new model, and you really need a new set of capabilities to do this. So first off, the modern application stack is incorporating a broad range of technology. So, gone are the days of applications being a simple web app backed by a SQL database. Now in this more modern application world, where you have these streams of data coming in, you need to process this data, you need to persist this data. You'll still have your web application components, you'll run those in containers, but you're really seeing this convergence of traditional application architectures and big data analytics architectures moving together to create these new kind of cloud-native application architectures. And so, when you have all these different components, that's great. That forms the foundation for these new applications. But you're also going to need to have the expertise for you to be able to build these services and pull them together, to integrate them, and to deploy them and to manage them with a high level of reliability and scale them out as your applications grow. And on top of all this, you're going to need to have a DevOps culture where you're able to quickly add new features, check them in, test them, release them, roll them back, and you're going to need to have like a modern CI/CD tool chain for doing that. So, to kind of recap these, application architecture is moving towards these what we call cloud native or modern applications, where you have data and analytics combined with the application. These are complex distributed systems, and you need to have the engineering knowledge to pull these components together and to operate them. And you need to have a DevOps culture where you're able to quickly build new features, push them, experiment, roll them back, and do this with high visibility across the tool chain. And so, a lot of companies are looking to cloud service providers to help give them these different capabilities. And so if you look at these modern cloud providers, they provide you with agility, elasticity, and scale. And so, building this out here, if we take a look at something like Amazon, they have infrastructure as a service as a base component of it. And then on top of it, they offer a broad range of application services or platform services. So container orchestration, continuous integration, Hadoop, big data analytics, queuing, database search, all these sorts of capabilities that you need to build these new modern business applications on top. And so there's a lot of benefits on going to the cloud, and that's where we see a lot of these applications being built. But like almost any technology, there can also be limitations, and these are the things that our customers talk to us about and are very concerned about. So number one, our customers are concerned about lock-in. They don't want to be tied into any single vendor. They need these capabilities, but they also need to have the flexibility and control, and to be honest, some leverage over these vendors, so they're not locked into just any single cloud provider. More and more people have been discovering that there's a lot of cost involved in going to Amazon and other cloud services. So, the bandwidth that you send between your applications, between regions, as you transfer data in and out, all these things have costs associated with them, and the bills really add up over time. And a lot of customers are discovering that while you definitely get the agility, there's a high price that's to be paid for that. And then finally, you have less control. You're really at the mercy of these cloud service providers on when they want to add new features and new capabilities on top of their platforms. In addition, you have concerns around data, controls around or the ability to control your strategy and where you're going. And so these are all just concerns that people have as they're moving into these cloud platforms. And so this is really where Mesosphere DCOS comes in. So with Mesosphere DCOS, we give you the same sort of cloud platform capabilities you would expect and that you need to build your applications, things like container orchestration, continuous integration, deployment, data and analytics, rich data services. We wrap that on top of a proven stack. So we use Apache Mesos as the kernel for our data center operating system. So this is a proven container or platform resource manager, proven to run at tens of thousands of nodes. And we add operations capabilities on top of that, security and multi-tenancy. And with DCOS, you can get these same sort of cloud-like services, but you can run them in your own data center, or you can run them across any cloud provider. So you get these same capabilities, but you're not locked into any infrastructure provider. So this gives you flexibility if you are in your own data center right now and you have a plan to transition or start using some cloud services. You can start building today in your own data center and have the flexibility to move there. Or if you're doing the opposite, you're starting to build in the cloud, but you don't want to get locked into any vendor, by building on top of DCOS, you have that flexibility to be able to bring it back into your own data center or to move to any other cloud provider. And so basically, one way to look at DCOS is that um, we pool all these resources together in your data center and give you like a single data, or sorry, one single giant computer. And this is a quick example here of what our dashboard looks like. And if you drill down, we have a catalog of services you can deploy. So we have things like DataStax, Confluent, and of course we have Alluxio, who we're chatting with today. And so with a single click, you can install any one of these services into DCOS, into your data center, or on any cloud that you're running DCOS. And so a couple examples of customers here that are taking advantage of DCOS and the rich services that we have on top of it. One of them is Verizon. Verizon's building a platform for building IoT applications. And they're a DCOS customer. They have huge streams of data coming in that they need to ingest, process, and persist, and then have applications running on top of it. Another great story that we have is Esri. So this is a company that works on geospatial mapping technologies. And again, they have a very similar pattern where they have streams of data coming in from a broad range of sources. They need to ingest that. They process it in real time with Spark, persist it out to Elasticsearch, and they have rich mapping capabilities on top of that. And they do this across hybrid clouds. And so with that, I'll pass it over to Neena to give an introduction into Alluxio.
Thank you, Keith. Now that you've heard about Mesosphere and the DCOS offering from Mesosphere, I'd like to then talk to you guys about Alluxio. And just to give a little bit of history on Alluxio, since not everyone might be familiar with what Alluxio is about. It started at UC Berkeley Amp Lab in 2012, same place where Apache Mesos was conceived. And some of you might be familiar with it because it was originally called Tachyon. It got rebranded to Alluxio last year. It is open source under the Apache 2.0 license. And we have 1.4 release that has been out since January, available now, and then the next release coming up in June. So when you look at Alluxio, what was the reason for Alluxio being conceived at Amp Lab? And I want to really take you back a little bit. Probably this is 10 years ago. Where we had big data just coming up, and the ecosystem for big data was really very simple. You had Hadoop MapReduce and Hadoop HDFS. Both of those would be running on the same set of nodes. And then from this very simple ecosystem, if you look at what things are today, you obviously still have Hadoop MapReduce and Hadoop HDFS. But on the compute side, Spark obviously is very, very popular, but there are other popular compute engines like Flink or Storm or Samza, or there's probably 30 others that we are not showing in this picture. And on the storage side also, there has been an evolution where instead of data being stored in HDFS like it was originally, people are now storing data in other types of stores, whether it's a cloud store like Amazon S3, or whether it's an on-prem store like Ceph or EMC ECS, or even Huawei Ocean Store. And so the result of all of this is when you look at what's happening for somebody who's doing compute, you essentially end up with this spider web where the different compute engines are trying to talk to the different storage engines that are out there, and each one having to manage what each, how to access the store and how to get data in and out of these stores. And this is the problem that Alluxio was designed to solve. So Alluxio is a file system that sits between compute and storage. The architecture here, if you see, is no longer compute and storage on the same nodes as it was in the original Hadoop MapReduce and HDFS architecture, but it has actually got disaggregated where the compute is running on a set of nodes and storage is completely disaggregated. It could be on-prem object stores or on-prem file stores, or it could even be in the cloud. And then actually in this architecture, you could have compute on-prem and storage in the cloud, or vice versa, or compute on-prem and storage on-prem and in the cloud. All of these combinations are all possible with Alluxio in the architecture, because what Alluxio essentially allows you to do is to enable you to run applications that can access data from any storage system at memory speed. And memory speed is the key differentiator here, because the Alluxio file system is running on the same nodes where your compute is, so where your Spark compute is running, for example. And it is essentially bringing the data from the remote storage, whether it's an on-prem remote storage or in the cloud remote storage, into the Alluxio file system in memory, and hence providing the fastest I/O access for the compute to that particular data. And so if you continue to think about this particular architecture where compute and storage has got disaggregated, this is actually one of the trends that's happening in 2017, where this decoupling is happening. This is a code from O'Reilly for what's happening in terms of how compute and storage are going in the big data space. And this also is very much in line with what's happening on the open source side of Alluxio, because it is one of the fastest growing big data projects. And even as you compare it to some of the other big data projects that you may be using already, you can still see how the contributor growth in Alluxio is, where we have over 500 contributors from more than 100 organizations, and running Alluxio and some of the largest clusters in the world. And the reason people are choosing to run with Alluxio is a couple of different things, right? First, Alluxio, unlike other ways where you may be thinking of accelerating the I/O, actually co-locates the data and compute together and provides memory speed access to the data for the compute. It virtualizes across different storage systems, so you can mount different storage systems under Alluxio, and Alluxio will provide a unified global namespace to the application. It is a scale-out architecture, which is the way the whole world is going today, where you add more nodes and you get more capacity. And then finally, this is really key, is Alluxio provides the same HDFS file system API that applications are using today. It is all software, so you can actually deploy Alluxio in an existing cluster and take advantage of it. You don't have to recompile any application code. You don't have to add a new piece of hardware. So it is very, very seamless to basically deploy Alluxio in existing clusters or in new clusters, and get the benefits that Alluxio brings, which is unification. And what I mean by that is, if you have data in different data stores, now you can, with using Alluxio, you can essentially be able to do any kind of compute or workflows on that data in any store, whether it's on-prem or in the cloud. You get the performance benefits, and what that means is because the data is sitting in memory, you get the highest I/O, and hence your compute will finish much faster than if you had to pull it from remote storage. And then finally, it gives flexibility, because what we are seeing is customers want to have a choice of how they grow compute and storage. They don't want to be locked into growing them together, which is the traditional model. Instead, you can, with Alluxio in the middle, you can grow compute if you need to do that, or you can grow storage if you need to do that, independently of each other, and grow them as you need to grow them. And because of the benefits that Alluxio brings, you can see that it has been deployed in some of the largest customers and partners, well-known names here, which is just a sampling of some of the places where Alluxio is being used. I'll also talk about some very specific use cases of Alluxio, and there are 5 that I'll go through really quickly. So let me start with the first one. The first one is from a company called Chunar in China. It's equivalent of Expedia here in the US. And Chunar is actually using Alluxio to process data from both HDFS and Ceph. And they're processing that data using Spark and Flink. You can see it's a large deployment. And they've been running it in production for over 9 months and essentially being able to do processing on data from both data stores that they have without having to move data from one store to the other. So they're able to do data sharing. They're getting improvements in performance from 15 to 300x speed up. And they're able to use processing, 2 different kinds of processing engine on the data for different applications. The next one I wanted to talk about is from Baidu, also in China. So in Baidu's case, it's a simpler stack because they have Spark as the compute running with Alluxio on the same nodes, and then the data sitting in the Baidu file system, which is a distributed file system across many different data centers at Baidu. And again, with Alluxio, Alluxio keeping the data that was of interest to Spark, Spark SQL that their analysts were running. With the queries that used to take 100 to 150 seconds to finish, now it was finishing in about 10 to 15 seconds. So they saw almost 10x improvement in the performance of the queries that were going on, and able to do, obviously, the faster you can get information, the faster then you can take decisions based on that information. So they are again very they're really able to see the benefits of Alluxio and see how it's helping their business. The next one I wanted to talk about is a completely different use case, which is from Barclays in UK. So in Barclays' case, the data that they were interested in processing actually sat in a relational database, Teradata in their case. And they were able to, using Alluxio, bring that data into Alluxio and then iterate on it much faster than what they were able to do otherwise, because the Teradata for them is their production system. And so getting access to that data was not easy without disrupting what was happening in production. Now they're able to bring it in, and their machine learning folks are able to train the models and generate new models for risk management and iterate on the data over and over again, as opposed to having to pull it from Teradata every single time. And so they are able to bring the data once into Alluxio, and then all the analysts are able to use the data from Alluxio. So they reduce the load on their production database, and the analysts are able to iterate on it much faster. And their quote literally was that what was impossible before for them to do is now possible for them to do. The next one I want to talk about is actually a use case from here in the US, a large retailer who again had a very simple stack in their case, Spark with HDFS co-located, and with the Alluxio layer in the middle. They were able to again run interactive queries on the data, whereas earlier the queries used to be much slower. They have been able to see about a 5x speed up in the queries consistently. So not only is it faster, but also the query results are much more consistent. In other words, unlike prior to the Alluxio case, where sometimes they would finish slower or faster, now they see very consistent results with the query, and that has really changed how their analysts can gain insights from the data. And then the last use case I wanted to talk about is a major IT vendor. Theirs is also very interesting because their data was distributed across multiple data centers across the globe. And with Alluxio, they are able to pull the data into Alluxio and run analytics on their worldwide data, which earlier was not possible because, as many of you know, there are regulations around, especially data in Europe and where data from Europe has to be stored. Similar to what there is, for example, in the financial industry, when you move data, there's a lot of regulations around how you are storing that data. With Alluxio, both in the financial industry as well as in this case, because the data is in memory, it is not persistent, And so you can bring it into Alluxio, do your analytics on it without having to worry about any of the regulations. And in their case, they were able to pull the data in and do analytics on all the data without having to worry about, how do I bring it over given the regulations that were on there. So you can see their quote is they're getting insights on all their data, which was earlier not possible for them. So in summary, what does Alluxio bring? So Alluxio is a memory speed file system which unifies data across different compute frameworks and storage systems. It has been adopted by some of the industry leaders. I gave you guys some examples. There's a rapidly growing community that is adopting Alluxio. And finally, we are really excited to now become part of the ecosystem within Mesosphere's DCOS. And we'll talk about it in a minute here as I hand it back to Keith. But we're really excited to be partnering with them and bringing this joint solution to you. So,
Thanks, Neena. We are equally excited to be partnering. There's a lot of interest around this. So why are we better together? So in general, for data services on top of DCOS, we spent a lot of time building out an SDK which helps partners like Alluxio integrate. But with DCOS, we provide you with a single command or from the UI, a few clicks, you can install services like Alluxio. So if you have DCOS in your cluster, then just a few clicks, you can have Alluxio up and running. We make it really simple for you then to manage these services. So most people don't want to just deploy these applications or these distributed stateful services. They need to do things like upgrade them as new features come out. They need to manage the application configuration. They need to monitor them. And in the case of when you are persisting storage, you want to make sure that those volumes are safe and that if servers die, you're going to be able to recover from that. So what we do is make it simple for you to deploy all these different stateful services, including Alluxio, and to manage them with a similar process there. And then finally, we make it simple for you also to scale these applications. You can add more instances when necessary. You can resize them, and so on. So we give you that elastic scaling with infrastructure. And so this slide here shows kind of a quick architecture of what it looks like. So at the bottom of the stack, you have any infrastructure, whether that's on-premise, private cloud, or public cloud. And then on top of that, you have Mesosphere Enterprise DCOS, which allows you to run these distributed applications and services as simply as running applications on your laptop. And then at the top of the stack here, we show Alluxio Enterprise, which enables you to unify your data at in-memory speeds. To install, this is a picture from our catalog called Universe. Alluxio is available in there. You can click install and it immediately begins to provision out. Nice and easy. You'll see other different services in here as well. Things like Apache Spark, DataStax, Confluent, Elastic, HDFS, all available in the Universe, all available to install just a couple clicks. And then without Mesosphere DCOS, provisioning out these distributed systems is more manual. And with DCOS, we make it really simple for you to do the install and management of these systems like Alluxio.
Yes, so to add to that, you have DCOS running, you have obviously provisioning and management of these systems using DCOS. And then when you're running a big data stack and say running Spark with HDFS or some kind of a store, what installing Alluxio Enterprise Edition then does is gives the application a unified view of data across the different storage systems. So you could have data in HDFS, you could have data in some other on-prem system, you could have data even in a cloud storage system. And the application using Alluxio will see all of them through one global namespace. And then in addition, with the with Alluxio being, like I said, in the memory of the or file system in memory on the nodes where compute is running, what you will see is high performance and predictable SLAs for analytics workloads using the different compute frameworks. And so together, when you think of what you're building in your data center, with Mesosphere, you get all the automation and provisioning of the applications. And then Alluxio in a big data stack then allows you to process data in your existing Hadoop cluster faster, as well as allows you to process data from different types of stores, whether it's on-prem or in the cloud. And so what we are actually going to be doing next is talk about a big data stack in the context of DCOS. So again, it's the picture that you saw earlier where you have the physical infrastructure and then DCOS. And then as applications on DCOS, we have Spark and Alluxio running, as well as HDFS. And we have some data in S3. And all of them, both S3 and HDFS, are mounted as folders into Alluxio. And we will show you essentially 3 different things related to the stack. The first thing is a demo of how easy it is to actually install Alluxio using the Universe catalog. So we'll show you that, and then we'll show some of the benefits of Alluxio in the stack using an example of count. So you're running data, you're running count as the job on some data. And then the second thing we'll show you is how easy it is for you to access data, whether it's from S3 or HDFS, or even move that data around from one system to another. And so that's the next part of the webinar today. And I'm actually going to hand it over to Adit, who is going to run and show you guys this, the demos.
Thanks, Neena. I'm going to show you the stack that Neena outlined in action. We have a pre-deployed DCOS cluster with a Docker registry running. The Docker registry will be used to host Alluxio Enterprise client images and also Spark images to run the Spark driver and executors. What you see on the screen is the DCOS web UI, and I'm going to run through first installation of Alluxio through Universe. The first step is to find Alluxio in the Universe, click on install and go to advanced installation. After obtaining a license from Alluxio, the next step is to paste the base64 encoded license into the license field in the Alluxio Enterprise installation box. We configure Alluxio to use an Amazon S3 bucket as understorage, and we check the Docker publish box to make sure that the images are published to the registry I showed you before. We specify credentials to access the S3 bucket in the S3A tab. We review the install configuration and click install. It's that simple. Now, once we've reviewed the configuration, Alluxio Enterprise Edition is being installed on the DCOS cluster. We can go into the Services tab and look at the status of the installation. There are a few tasks that are being run at the moment. You can also look at the Mesos UI to monitor the tasks in addition to the DCOS UI. The 2 tasks that are running right now are building the Docker images for Alluxio and Spark, like I mentioned before. what we're doing now is that we'll log into the leader for DCOS on each of the 3 shells that I have open. We'll use the first shell to run the Alluxio client. We'll use the second shell to run the Spark driver. And in the third shell, I will demonstrate the unified namespace with HDFS when I mount HDFS into Alluxio's namespace. We just saw that the Docker 0 Alluxio task finished, and this has published an Alluxio client image into the Docker registry that we had set up earlier. On the shell on the top, in the topmost shell, we are running the Docker image for the Alluxio client, which we'll use to list the contents of Alluxio. Now, once we list the contents, you will see that the contents of the S3 bucket that was configured as understorage for Alluxio are loaded into Alluxio's namespace. We're waiting just a few more moments for Alluxio to be installed. Once Alluxio is installed, we will see that there will be a master task and worker task with status running in the DCOS UI. While Alluxio is being set up, we are running the Spark driver on the second shell. Now we can see that Alluxio master and worker processes are up in DCOS, and when we do a listing on the root of the Alluxio file system namespace, we see that it is pre-populated with 3 files. Sample 1G, which is the 1 gigabyte file that we will use for our Spark count job, and a couple of other files that were present in the bucket that was mounted to the root of Alluxio. In the second shell that I have open, we are running the Spark driver, which will run the count job to count the number of lines in the 1 gigabyte sample dataset, accessing data through Alluxio from the S3 bucket, and then directly from Alluxio memory to demonstrate the performance benefits with Alluxio. We set the log level to info to measure the timing information for the job to finish. We wait for all Spark executors to come up before we run the job. You can see that all tasks are running now, which means that we're ready to launch a Spark job on top of Alluxio. We specify the file path that we will use for the count job, and then run the count job for the first time. The first run of the count job is accessing data from an Amazon S3 bucket, and it will take longer than when we access it through Alluxio. As you can see, the locality level was process local, which meant that there was no locality at this point, and the job took 32 seconds to finish. What we're seeing now is the second run of the same count job. It took only 5.3 seconds to finish. This time, data was accessed through Alluxio, and when I list the contents of the directory in Alluxio, it showed in memory, which meant that the file is being managed by Alluxio. So next we have a pre-deployed HDFS on the DCOS cluster, which we'll use to demonstrate the unified namespace feature. In the bottom shell, I have launched the HDFS client. I'm listing the contents of the HDFS client, which has a README file in it. Now the next step that I'm going to do is mount HDFS into Alluxio's namespace so that you have both S3 and HDFS available at the same time. HDFS has been mounted. Listing the contents of the HDFS directory will force Alluxio to discover what was present in HDFS. The not in memory annotation means that only the metadata for the file is loaded into Alluxio, but not the data at this moment. Now I'm copying the file from HDFS into the root of Alluxio's namespace, which is managed on top of an S3 under storage system. Listing the contents of Alluxio's namespace, you can see that you have access to files from an S3 under storage and an HDFS under storage at the same time. That was the end of the demo. Thank you.
Thank you, Adit. That was helpful. Hopefully, people got a sense of how Alluxio itself works, as well as how easy it is to deploy Alluxio in a DCOS environment through the Universe catalog that is available. So in terms of next steps for the audience of the webinar, there's a lot more material available for you to do things with. There's two blogs, one from Mesosphere and one from Alluxio, and you can see the links and go read about the joint solution, which we are very excited about. There is also things you can do today. So you can install Alluxio from the DCOS Universe. For this, you do need a trial license of the Alluxio Enterprise Edition, and feel free to either send an email to sales@alluxio.com or come to Alluxio's website and request for it there. And Mesosphere, similarly, if you have more interest about it, you can ask them for more information at sales@mesosphere.com. Keith, I don't know if you want to add anything more to what I already said for you guys' side.
Yeah, this is great for the next steps. I mean, just to make kind of the use cases that we hear from our customers concrete for everyone that's listening is that we'll hear from customers that say, hey, we're using Apache Spark now, we love it, but we're having challenges scaling it. And so what we want to do is roll it out not just to 50 people in a team, but we want to roll it out to 500 or 1,000 people in our organization. And they say, but my data is also still locked into my Hadoop system. I can't move it. There's just too much of it. What can you do for me? And this is where Alluxio and DCOS and Spark together is really able to help these customers, because you don't need to pull all of your data out of Hadoop. You can keep it in HDFS where it is, whether that's in the same data center or whether that's on a cloud or a different data center, as Neena was showing in some of the examples. And you can run Spark on top of it and process that data and democratize Spark across your organization, give it to everyone. So lots of interest from financial services.
Okay, so we will head out to the Q&A session. So let me look and see what's available. What are the questions out there? So the first question is about, are there any long-term trial licenses for developers available? or what is the expiration time of the trial license? So I can take a stab at it. So for the Alluxio trial license, it's a 30-day trial license, and Mesosphere. I'll see if Keith. Do you guys want to talk about your trial license?
Yeah, so if you contact our sales team for well-qualified leads, we have trial license opportunity. You can also go to DCOS. We have a community project, so if you go to dcos.io, you can deploy DCOS from there. A lot of customers will just deploy a cluster out on AWS to kick the tires. So those are options.
So the other question that is being asked is, does this combination only apply for Mesosphere 4 Enterprise, DCOS, and Alluxio Enterprise? And what are available with the open source versions? So what I could say is the integration that is available is Alluxio Enterprise on Mesosphere DCOS. And I'll let Keith chime in about whether it's going to be available on the open source version of DCOS or just with the enterprise version.
Sure. So any of the services that are available in Universe could be deployed onto community or to enterprise. But most of our customers that are deploying this are enterprise organizations that are concerned around having support, having security, and things like that. And so I think the recommendation from both of our companies will always be that you should have an enterprise agreement with both of us. That kind of aligns everyone for success. Yeah. Neena, maybe you can take this next question. Should I pay for a Alluxio license in addition to DCOS Enterprise? Yep, so I'll take another question here. So Spark itself is claimed to solve the problem of slow reads from HDFS, holding as much memory or as much data in memory as possible. Why do we need an additional Alluxio in-memory layer in between? And one of the great things that Alluxio can do is it can pull that data in, it can cache it, so you can share that across Spark jobs. So what we heard from one of our customers is that they have like 500 gigs of data that gets loaded in.
There's another question on on the demo itself, is that if I understood correctly, data from S3 or HDFS has to be copied to Alluxio before processing via Spark. That is actually not the case. Both Spark and S3 are mounted into Alluxio, and the data is and the data is automatically brought into Alluxio when the application is accessing it. So you don't actually need to copy the data into Alluxio manually.
Yeah. Okay, there are a couple more questions. I'd like to really thank Neena and Adit for taking time to work with us to build this integration, and look forward to working with all of you out there that have joined today. Thank you very much.